So we know they're isosceles because these two sides are exactly the same, and these two sides are exactly the same. But there's a relationship with the ratio. If I do 1 divided by 1.42, what is 1 divided by 1.42? Anybody? 1 divided by 1.42? What do you get when you do 1 divided by 1.42? 0.7. And what do you get when you do 2 divided by 2.83? 0.7. Huh. Right? So these are similar triangles. There's always going to be the same ratio there. So what I'd like for you to do is, well, why is this not sticking to the slides? You don't want to do this. What I want you to do for a minute, I'm going to stop sharing. I want you to go to this Desmos link and kind of play with the triangles. So we're going to fill this out. Opposite the 45-degree angle is a 1 and a 1, and then a 1.42. And opposite the 45-degree angles was a 2 and a 2 and a 2.83, right? So what I want you to do is go to this link, play with the little app, make the circle bigger and smaller so you get some different numbers. And I want you to come back with different numbers, but you have to make sure that this is 90 degrees right here. Okay? So I'm gonna stop sharing. You're gonna go get 3 different sets of numbers and then come back. And they can be whole numbers, they can be not whole numbers, it doesn't matter to me. Does the link work? Okay. And the hypotenuse under the, exactly. And the trick is you got to make sure that that degree in the middle is always 90 degrees. I did do it, but I can't write it. Can you just write them down like on a scratch piece of paper or something so we can come back and put them in? So I'm going to share my screen again. Hopefully that doesn't take over yours too terribly much. So we had 1 and 1, 1.42. And we had 2 and 2 and 2.83. What's another set of numbers that you got? Anybody? My chat went away again, darn it. There it is. Yeah, so I want 3 more sets of numbers. What are, like, Mikhail, what's one more set of numbers that you got? Somebody put 5, 5, and 7.08 in the chat. 5.28, 5.28, and what was it? 7.48. And then I see somebody else put in the chat 4.75 and 4.75 and 6.69, right? So we notice that these are all isosceles. The 2 legs are going to be exactly the same, and they're opposite those 45-degree angles. right? And then the 90-degree side, the hypotenuse, is always bigger. But what is the fraction? So if we do the opposite divided by hypotenuse, 1 divided by 0, or 1 divided by 1.42, we got 0.7 before, right? We got 0.7 here. What's 5 divided by 7.08? Also 0.7? Everybody needs to get a calculator out. And then 5.28 divided by 7.48. Also 0.7. And then just because I'm not very much of a betting person, I'm going to put the last one in my calculator too. Still 0.7. All of these are going to have the same ratio because there's a pattern here that we're going to kind of look at. Okay. Say it again. The decimal after the 7 might be a little bit different. But let's look and see what the pattern is. It has to do with the square root of 2. So let me get my Screencastify back. And I'm going to make this a little bit bigger so it's easier to see. Over here in the corner, we've got x, x, and x on the square root of 3. So if we draw a little, we call this a reference triangle. We've got 45 and 45 and a 90 degree. It means my two legs are going to be exactly the same. And if I take that length and I multiply it by the square root of 2, which happens to be that 0.7, we're going to end up with a hypotenuse. And this works in every triangle. So it's a little bit faster and easier depending on what you're given than if you are doing trig. Okay, so let's look at example number 1. If I know my two legs are the same, then what's x equal? What's x equal if I know my two legs are the same? 8. And if I know that the hypotenuse is that same side times the square root of 2, can I just go in my calculator and do 8 times the square root of 2? What's that equal? Somebody get out a calculator. I got 11.3 as well. Hopefully everybody did. Okay, 11.3. So what do I know about question number 2? My two legs have to be what? Two legs of the triangle have to be what? The same. So is x equal 25 or y equal 25? X or y? I've got y is this side and x is the hypotenuse. So this time y equals 25 because that's the leg. How do I find x? We can absolutely do a squared plus b squared equals c squared. Is there an easier way if I know that the hypotenuse of an isosceles triangle is always x times the square root of 2? Let's do it both ways. So 25 squared plus 25 squared equals c squared. So what do we get that way? Anybody get C? Mm-hmm. 35.35. What is 25 times the square root of 2? Just put this in your calculator. 25 times the square root of 2. So you can do it on your phone. Do you have an Android or an Apple? Oh, see, I don't have an Apple. But it should work similarly. You got to turn it sideways. Like that. And you should be able to do 25. It looks like a little check mark, 2. Like that. I realize it's backwards, but it should be 25 square root 2. On the iPhone, it might be backwards. You might have to do 2 square root and then multiply by 25. So I got the same thing, 35.35. Yep. Which one's easier? If you know the hypotenuse, right, you could do that. Here, there's an easier way though. So I know my legs are going to be the same. And I know that this is going to be x times the square root of 2. So can I solve that equation? Can I just divide by the square root of 2? So this is supposed to be a shortcut that we're learning today. So it's brand new information. And it really is a shortcut if you could kind of master the pattern, just like trig and inverse trig. So this is exactly like solving 19 equals 2x, except I've got a square root of 2. So in your calculator, you want to do 19. And if I'm on my phone, I got to go back to the sideways view, the landscape view. 19 divided by square root of 2. 19 divided by square root of 2. And in an iPhone, I think you have to put the number and then tell it to square root it. So it'd be 2 square root and then not divide 19 by that. And what do you get? What? Because you did square root of 2, square root, and then divide by 19. You want to do 19 divided by 2 square root. I think that's what you want to put in the iPhone. Again, I don't have an iPhone, so I'm going on memory. You should get 13.4. Is that what you got? So maybe let's go to Desmos. If I open Desmos, can you see it? Okay. So 19 divided by, and we got to go into our little tool thing because I don't know the shortcut for it. 13.4. You don't have to be in degree mode here. It doesn't matter what mode you're in. Okay, and I see in the chat lots of people have gotten that, so that's fantastic. I think that was all that's on this slide. Let me zoom back out and make sure. So basically our pattern is the 2 legs are x and the hypotenuse is x on the square root of 2. So let's try these ones. Still, the 2 legs are going to be the same, and the hypotenuse is going to be that leg times the square root of 2. The idea here is this is a shortcut. So what do I know about triangle 1? 13, absolutely. And William, I'm going to try in Desmos SQRT to see if I can do that shortcut. So the two legs are congruent because the two angles in an isosceles triangle are congruent. So now we can go to Desmos and we can do 13 times the square root of 2. And what do we get? Should be something bigger than 13. I like 18.4. So what about number 2? Number 2 makes it a little bit different because we're given the hypotenuse. So these two sides have to be the same. So this is x times the square root of 2. So we've got to solve that equation. 30 equals x times the square root of 2. So I've got to divide by the square root of 2 to solve that one-step equation. So this is my opportunity. I'm going to check. 30 divided by square root. Hey, that worked. 2. William, I love it. You got all my hacks. 21.2. So we go back here and double check and make sure that that seems like it works. 30 divided by the square root of 2 and 20.2. And those should be the same, right? So these shortcuts are used a lot in a couple of very specific places in math, but they like to be tested a lot, especially on the SAT. So I'll be honest, with COVID, I have no idea if the SAT is going to continue to be a thing for you, but this is definitely something that is helpful in the SAT. What would I do with number 3? Is there a problem with number 3, or can I do it? It's kind of a trick question. Okay, how do I do it? What do I know? So we're saying 3 and y are congruent. How do we know 3 and y are congruent? They are the legs, but what kind of triangle do I have here? Is it isosceles? I do have a right triangle, but I'm tricking you. This is not an isosceles triangle because I've got a 30-degree angle here and a 60-degree angle here. This is a scalene triangle. I'm making lots of you very mad at me right now. This one is not isosceles, so we can't use the same pattern. We need a new pattern for the 30, 60, 90 triangles. Okay, so we can't do this one the same way. Put a little X there. And if you did 3, 3, and 3 on the square root of 3, that would be perfect for a 45, 45, 90 triangle. So if I had 3, 3, 3 on the square root of 2, that's if I have an isosceles triangle that works. So let's go to the next slide and see what our pattern is for 30, 60, 90, because I think we have a pattern in the next slide. We're going to start with a different Desmo, but it does the same thing. On your piece of paper, you're going to do the small side, the medium side, and the large side. So small, medium, large, small, medium, large. Go to this link and find me 3 numbers, okay? Go to that link and find me 3 numbers. I should have tested the link before I stopped sharing, but you've already done this once, so I think you can figure out what to do. Yep. So you're just going to drag one corner of the triangle. It should stay a 30, 60, 90 triangle. I got a little bit better at making these. I had never used these before. So just find me 3 sets of numbers that we can put in. And play with those triangles. See how they grow. It was oddly satisfying to learn how to make those. Did the link work for everybody?
It's not working for me. This slide, so it's not working.
It's not. Oh, because you can only get there from the Google Slides, not from the Pear Deck.
Well, no, the Pear Deck was working for the first one because you could draw that. This one is not working
Gotcha. You can only do one thing on a Pear Deck. We've sent them emails saying that, and they just don't. So you can move it at the 90-degree angle, and then you can make it bigger or smaller. So if I find 3, let's go to 3. My numbers are 3, 5.2, and 6. And if I make that a 4, I've got 4, 6.93, and 8. Do we see a pattern forming? Oh, it'll only let me make it bigger with the 60-degree angle. That's weird. So let's go to 5. 5, 8.66, and 10. It is. So this short leg, the one opposite the 30, is always half the size of the hypotenuse. Or if you think about it the other way, the hypotenuse is always twice as big as the shortest leg. And then this one has a pattern too. It's just a little harder to see. So let's see if we can figure that out. So I've got 3, 5.2, and 6, and 4, 6.93, and 8, and 5, 8.66, and 10. So the ratio of the large over the small, 1 divided by 2.01 is basically 2, right? And 4 divided by 2, the large divided by the small, is basically 2. So this is what Mikhail just found out. I'm sure lots of people noticed it. He was just the first one to voice it. The small side and the longest side are always going to be half or double, depending on which way you're going. It's the medium and the small that's a little bit different. So if I do medium divided by small, 1.74 divided by 1 is 1.74. What is 3.47 divided by 2? Anybody? We're at 1.735. Does that round to 1.74? It does. So if we do 5.2 divided by 3, we still get that 1.7. This rounds to 3. Desmo is not 100% accurate, so that's part of the reason why we've got some rounding issues. 6.93 divided by 4 is going to be 1.73. And 8.6 divided by 5 is again going to be 1.72. The last thing I want you to put in the calculator is, what is the square root of 3? So you're putting in square root of 3. Square root of 3. You get 1.73? That, my friends, is our pattern. So instead of the isosceles triangle, where we had x, x, and x on the square root of 2, because we've got two sides that are the same, we use the square root of 2. We've got a scalene triangle where it's x, 2x, and x on the square root of 3. We've got a scalene triangle, all three sides are different, and we're going to use the square root of 3. Whereas in the isosceles triangle, we had two sides that were the same, so we used the square root of 2. That is 100% an accidental coincidence that is very helpful. So let's see if we can figure this pattern out. And then we'll practice them a little bit. So if I know the small side is 5, which side is 10? Small side is 5. So which side is the hypotenuse? Absolutely. Because that's the 2x, right? So my reference triangle, if this is the 30, is x, 2x, and x times the square root of 3. So you can, absolutely. You can go back to Pythagorean theorem. That works 100% of the time. So c squared minus 5 squared is going to give you x squared. Or we can do x times the square root of 3. So whichever way you want to do it, this will work and this will work. Whatever you see. So when you get your answer, let me know what you got. I got 8.62. What would I do for number 5? What do I know and what can I figure out from that? So again, I've got my 30-degree angle. So I've got x, got my right angle, that's 2x, and then my 60-degree angle, that's x on the square root of 3. So which one is going to be 28, x or y? Because that's double, right? And then how do I find y? Do I use Pythagorean theorem or do I use the x on the square root of 3? Doesn't matter. A squared plus b squared equals c squared. Or x on the square root of 3. So 14 square root of 3. Whichever one makes you happy when you get an answer for y, let me know what it is. Love it, William. If you did Pythagorean theorem, you would have to do the 28 minus the 14 equals y squared. And you should get the same thing. It is 4.2, 24.2. Let me see if I can make that more clear. So what about here? I can make my reference triangle again. So I've got a 30, which means I have an x. I've got a right triangle, which means I have a 2x. And I've got a 60 degrees. That means I've got x on the square root of 3. So what am I given? What does that 32 correspond to? That's the hypotenuse, right? So that's the 2x. So which side is 16? X. And then I can use Pythagorean theorem. 32 squared minus 16 squared equals y squared. Or if I remember that this is x on the square root of 3, I know the x is 16, so I can do 16 square root of 3. $27.7. Did anybody else get that? I haven't picked up my calculator yet. 27.7. Awesome. So again, these are special right triangles. They're special right triangles because they're always 45, 45, 90, x, x, x on the square root of 2, or 30, 60, 90. They're all divisible by 3. It's 3 different sides. So x, 2x, and x on the square root of 3. They are still right triangles, so we can 100% use Pythagorean theorem if we've got 2 sides and we're looking for an angle. So let's look at the next slide, slide 8. and see what we can figure out there. See if they're all pretty straightforward or if they start getting tricky. I've got my small side, that's going to be x. I've got my hypotenuse, that's going to be 2x. And I've got my big side, that's going to be x on the square root of 3. So if you're still a little bit confused, once you do that, you can set the two things equal. Wherever you have the number, you can write an equation there. So 2x equals 46. So what's my small side going to equal? 23. My small side, I've labeled x, but they've labeled y. So that small side is 23. Sometimes the variables, because we use the same variable multiple times, get students confused. So then I'm looking for this longest side, that biggest side. I know my x is 23, my small side is 23, so let's just put a 23 in here. 23 times the square root of 3. Guess what? Should be something bigger than 23 and smaller than 46. I missed the 2. Anybody get a number? 39.8, 39.9, either way. Yep. Beautiful. Love it. Number 8 gets a little crazy, right? So we've got the small side, we've got the hypotenuse, and we've got the big side. So we know the small side is half of the big side, and we know, or of the hypotenuse, and the big side, so this is x, this is 2x, and this is x on the square root of 3. This, my friends, is my equation. So we haven't done one like that yet. So we've got to do 20 equals x on the square root of 3. We're going to divide by the square root of 3 to get the x by itself. And that's back to what we were talking about before. How do you put that in the calculator? Depending on what kind of calculator you have, the answer to that question is going to be a little bit different. But for the most part, we're going to do 20 divided by square root of 3. So what do we get for that small side? This one right here. Anybody got that? 11.5. Yay, Sammy. That's my pink X, which is their black Y. So my 11.5 needs to come down here. This is the problem when you start using the same variables for different things, right? I'm using X for their small side and they're using X for the hypotenuse. So if I know the small side is 11.5, what's the hypotenuse? 11.5 times 2. 2 times 11.5. Guys are sleepy today. Is it just that we're doing traditional learning and not exploratory learning? Did anybody get 24? Did I do that weird in my head? I had 23. I was checking. Thanks, Daniel. So last question, question number 9. This is like as hard as I will give you for the use in this class. You go to math analysis and you get some harder ones. So 30 is my X. y is my 2x. Oh, actually, this one's not as hard as I thought. And this is x on the square root of 3. So this guy is my equation. It's where I have something on one variable. So what's x equal? If we're not sure, we can divide by the square root of 3. If you do 9 times the square root of 3, you definitely get 15.58. But now we've got to divide by the square root of 3 in order to solve that. By the square root of 3. And what happens when you multiply something by a number and you divide something by a number? So if I do 9 times 3 and then divided by 3, don't those cross out? Yeah, so if I do 9 times the square root of 3 divided by the square root of 3, they're still going to cross out. And we should be left with 9. So x equals 9. That short side equals 9. And that just takes some practice with radicals that we don't have time to invest in. If my short side opposite the 30 degrees is 9, what's my longest side, my hypotenuse? 18. That's the pattern that's super helpful. The square root of 2 and the square root of 3 pieces are extra, they're bonus, but that small side is half the size of the hypotenuse is the really powerful one. That's a really easy shortcut. I think we've got 5 more slides and then we're going to be done for today. Your homework is going to be to research catapults because tomorrow you're going to start building catapults if you haven't already. Okay, and we're going to see how right triangles fit into catapults. If we go to slide 9, we've got a crane. Let me zoom out so I can see the whole thing. We've got a crane, right? Picking up this giant bucket thing. I don't even know what that is, right? But cranes use trig all the time. If the top angle cannot be more than 30 degrees, so we're going to make this angle 30 degrees. What are the possible lengths for the triangle if the center cable, that vertical cable, is 6? How'd you get that? So if we do 6, so this is my, let me get a different color. This is X. Oh, I was supposed to get a different color. Let me erase that for a minute. So this is my 30. That means this is my 60. And this was 6, right? So if I have X and 2X and X square root of 3, this is my equation. So I have to solve that equation. So if X square root of 3 equals 6, do I multiply by the square root of 3 or divide by the square root of 3? Divide. The square root of 3 and the square root of 3 are going to cancel out. And what is the decimal for X equals 6 divided by the square root of 3? 3.4. So this side here has to be smaller than 3.4. So what's this hypotenuse? If that's going to be 2x, the hypotenuse has to be less than what? 3.4 times 2? Which is what? 6.8. Absolutely. So in my triangle, if this is 6, then this is 3.4, and this is 6.8. Does that make sense? Kind of, sort of, maybe? Just like trig, it's going to take us a little while to establish the patterns. So let's go to the next one. Slide 10. What are the possible side lengths of a triangle if the horizontal distance is 30? So if I say the horizontal distance is 30, which side is that? The up and down, the right and left, or the hypotenuse? Horizontal distance. Where's the horizon line in the sky? It is left to right. So this side is 30. Right? And the base angle cannot be more than 60. So this angle right here is my 60 degrees. So if I redraw that triangle a little bit, if this one is 60 and this is right, that means this is 30. And we said this was 30 feet. So opposite the 30 is the x. Opposite the hypotenuse is the 2x. And opposite the 60 is the x on the square root of 3. So if x equals 30, what's 2x equal? 30 plus 30, 30 times 2? Yeah. So this side here is going to be 60, right? That's the hypotenuse. That's the boom of the crane. And then what's the height going to be? What's this going to be? X on the square root of 3. If my x was 30, then that's just, say it again. 51.7. Awesome. So we can just use these ratios. It's kind of like when we did the golden ratio thing that was not such a great lesson, where we were measuring our nose and our eyes and our arms and I forget what else we measured that day and put together into ratios. That's all this is. Really, that's all trig is. So let's come here. We've got a red triangle and a pink triangle. Oops, I thought I was making it bigger. Let's read our words first. What are the possible lengths of the triangle if the box is 20 feet wide, 15 feet tall, and 40 feet long? So 20, 15, and 40. I think we're talking about the red here. So 20, 15, and 40. So if this is 20, and this is 15, and this is 40, what do we know about that triangle? Or what can we estimate about that triangle? What's the length of the base, like from here to here? Does that look like it's 40 or a little bit less than 40 or a little bit more than 40? You guys are killing me. If I've got this red triangle and it goes from the corner to the corner of that box, is the whole thing 40? Yes. And it didn't tell us, but it should have, that these are equilateral. So all of these are equilateral. And I think this goes to kind of what Mikhail was talking about yesterday with that gymnastics floor. If I slice this down the middle and it was 60 to begin with, is it 30 now? And this side is 60? Can we go with that? Yes. Okay. So if the whole thing is 40, what's this piece if I sliced it in half? Half of 40 is 20? Question mark. So can I put a 20 here? And a 20 over here? And that's opposite my 30-degree angle. So what's the hypotenuse have to be? We said it was an equilateral triangle, so the bottom and the right and the left should all be exactly the same. So that's 40 and that's 40. So how do we find the height? We've got two different tools at our disposal. The first one we sometimes like is a squared plus b squared equals c squared, right? Where do I put the 20? Is that A, B, or C? Mm-hmm. It could also be B. And then what's the 40? The C, the hypotenuse, always the hypotenuse. So when we do that, 40 squared minus 20 squared, and then take the square root, what do we get for B? What's this height? Should be less than 40 and bigger than 20. Did you subtract them? So you want to do 40 squared minus 20 squared equals B squared. 40 squared minus 20 squared equals C squared. I got 34.6 as well. Good. Awesome. And it's just practice of putting things into the formula, right? So we took an equilateral triangle, we divided it in half and made a 30, 60, 90 triangle. We could also have taken the 20 and done square root of 3. So everybody in your calculator, just for fun, do 20 times the square root of 3. I know, only math teachers think that's fun. Did you get the same thing? Yeah, absolutely. Okay, I'm going to erase all of this. Does everybody have it? Because now we're going to go talk about the pink triangle. Can I erase it? William says yes, I'm going to. So now we're going to talk about that pink triangle. Erase over here, everything in red, and we're going to switch to pink. So I'm going to read the words. What are the possible lengths of the equilateral triangle if the height of the triangle equals the height of the box? So the height of the triangle equals the height of the box. I thought I erased that. I don't know why that came back.
Yeah, I figured that was somehow what the eraser really does is just put the length right over it.
Oh, really?
Yeah.
Oh, look at that's crazy.
Yeah.
So the height of the triangle equals the height of the box is what it said, right? Height of the triangle equals the height of the box. And we had, this was 40 and 20 and 15, right? So the height of the triangle equals the height of the box. So that's 15, and it's equilateral. So again, I know this is 90, and this corner is 60, and this corner is 30, right? Because if I cut an equilateral triangle in half, I get two 30, 60, 90 isosceles triangles. Are we good with that? And these sides are the same. And this is half as big. So if this is x, this is 2x, and that 15, oops, let me get a different color. That 15 is x on the square root of 2 or square root of 3? 3, thank you. So if I solve that equation, right, for x, what do I have to divide by? Square root of 3. The square root of 3's cancel out on the right side, and we get x equals what? What is 15 divided by the square root of 3? 8.6, right? So I've got my equilateral triangle. I've got a height of 15, and I've got a base down here of 8.6 because that's opposite my 30-degree angle. It's a 15, by the way. So how do I find the hypotenuse? If I know the bottom is 8.6, that small side, how do I find the hypotenuse? Multiply it by 2. So 8.6 times 2 is 17.2. Perfect. You guys are going to be so tired of looking at cranes today. I think we've got 2 more slides, and then we'll be done. Okay. Slide 12. Says the smallest angles in these similar triangles can be no larger than 30, right? So I've got a 30-degree here and a 30-degree here, which means this one is 60 and this one is 60. What is the ratio of the smallest side to the largest side for each triangle? So small side to large side and small side to large side. What's the ratio of small to large? Small to large or small to large? If we've got 30, 60, 90 triangles, how are the small side and the hypotenuse related? Which one's bigger? Come on, y'all. Which one's bigger, the hypotenuse or the small side? The hypotenuse is bigger, right? And how much bigger is the hypotenuse than the small side? Twice as big. So the ratio is 1 to 2. The big side is 2 and the small side is 1. That's our x and our 2x. X and 2x. All right. So if I do know that the booms are 50 feet and 30 feet, so if this is 50 feet and this is 30 feet, what are all the other side lengths? So if I know this is 30, what's the small side? 15. And what's the medium side? What do I have to put in the calculator? Multiplied by the square root of 3 in this case. 15 multiplied by the square root of 3. Yes. And that's the hardest distinction to figure out. So I've got a 17.2. Oh, no, that's a different question. What is 15 times the square root of 3? Did you multiply? It should be something bigger than 15 and smaller than 30. Maybe I didn't hear you right. Would you get 18.6? 25.9. I think that's right. Brianna confirmed. Okay, so let's find the side lengths over here in this one. If I've got a 50 for a hypotenuse, what's opposite the 30-degree angle? Mm-hmm. And what's that measure on the small side? 25. We just divide that in half, right? And then what's opposite the 60-degree angle? So it's going to be the same, 25 times the square root of 3, which is, should be somewhere. What is it? 40.3? Okay. I clicked on the wrong thing. So if you drive into Norfolk, or actually if you drive up to Newport News, not into Norfolk, that's where this one is, there's a giant blue crane. Have you guys seen it? Driving up to Newport News across the HRBT? No? So if you go up there, there's a giant blue crane. It's called Big Blue. It used to be one of the top 10 biggest cranes in the world, but now there's so much in shipping industry over in Asia that they have all of the big cranes now. But Big Blue, when it started, was one of the biggest cranes in the world. It's where we build all the aircraft carriers for the United States military. Okay. It is, absolutely. So this is the bow of, I don't know if this is particularly an aircraft carrier, but my guess it is because all Newport News makes is submarines and aircraft carriers. Everything else gets made somewhere else. So this is like a real world example of what we have here in Hampton Roads. The equilateral triangles are 230 feet tall. So that is 230 feet. So I'm going to draw it over here so we can see it a little bit better. And it's going to be almost exactly what we did in the last problem. So I've got an equilateral triangle. I've sliced it in half into two isosceles triangles, and I've told you the height is 230. So what do I do now? How do I figure out what the sides of those triangles are? So I know this angle is 60, right? Because it's an equilateral triangle. And I know this angle is 60 because it's an equilateral triangle. And I know this angle has been cut in half. So what are each of the halves up there? 30. So I just had to cut some stuff apart. We can make it a little bit easier to look at by just drawing one of those. I've got a 30, I've got a 60, and I've got a 90. And I know this side opposite the 60 is 230. Which side is x, which side is 2x, and which side is x on the square root of 3? Which side is the smallest? The bottom. So opposite the 30 is the x. Opposite the 90 is the 2x. And opposite the 60 is x on the square root of 3. I've got three different sides, so I'm going to use the square root of 3. So opposite the 30 is the x. Opposite the 60 is the x on the square root of 3. And opposite the hypotenuse is the 2x. This is where I have two pieces of information. Just like with trig, that's where you start. If you have two pieces of information, that's your equation. So if I come over here where I have just a little bit more room, I can do x on the square root of 3 equals 230. How do I solve that equation? if I gave you 3x equals 230, how would you solve that equation? So we're going to divide by that square root of 3. Absolutely. So we come over here, get rid of that, get rid of that square root of 3 by dividing. And what's x equal? 230 divided by the square root of 3 equals, oh, I had a weird number in there. 132.8. Good. 132.8. Where does that go? What does that mean? What side does that go in here? Is that x or is that 2x? What's that x equal? Where do I put that in my drawing? What side is 132.8? The bottom. So this side is 132.8. This side is 132.8. This side is 132.8. That's opposite the 30 degrees, right? So if I know that this is 132.8, how do I find the hypotenuse? Multiply by 2. So what's 132.8 times 2? $65.6. Good. 265.6. That, my friends, is all three of those sides. 265.6. 265.6. So we did all of this crazy math, but literally the only thing we were told was the height of the triangle, and we could figure out everything else. So if we have the height of the triangle is 230, then the sides of the triangles are 265.6. 265.6. And these down here are half of that. 132.8 and 132.8. Okay. That is the last piece of notes that we need to learn for the rest of our projects for this unit. I'm going to stop the video. I'm going to stop sharing. Make sure you've captured all of those notes, okay? I'm going to put this video, I'll post it into the folder so you have access to it. If you missed anything, you need to go back and make sure you get the notes so that I can give you full credit. But that is the end of class, and I will see you guys tomorrow. Remember, no office hours today. Okay? See ya. Today's a normal day. Yeah.